Hey guys, once again it's Zion, City, the IT guy. Today I'll be answering the question 3 of the Southwest Regional Mock Examination 2020, Ordinary Level Computer Science Paper 2. The first question, let me take you to pen. The first question is talking about draw the circuit diagram representing the Boolean expression x equals to a bar dot b plus a dot b bar. These bars are inverters. That is a complement. To draw this, first of all, observe the circuit, the diagram. Realize that you have an AND gate here, an AND gate here, and an OR gate here. So we can draw the gates. Look for the size. Okay, the size is good. And put it this way. Excellent. Size. Yeah, this. Consider one as our AND gate and make it duplicate. Paste it here. We can have 2. Then let's draw our OR. Yeah. Good. We'll consider the OR gate. Then our A and B, put them here. A space B and A complement. Let's complement. We do the same thing for B. Because B also has a complement. Good. So what enters into this first AND gate? We have A bar dot B. So the A bar needs to enter. Let me take it from here. The A bar we need to enter. Here's the A bar. Into that. Then the B. Let's take the B. Let's keep break here. Good. Let's go with the B and see where it can lead us. Yeah. Good. That is A dot B. Now A bar dot B. Now A dot B bar. A Here's our A. Yeah, B bar. You can skip. Skip again. Skipping. Then we link with this. And now the OR. That's for our OR gate. A bar dot B plus A dot B. So we're adding this. Adding these two. We're ORing them. To come out with our X. That is that for that circuit diagram. Okay, the B part of it. Carry out the following conversions. 96 base 10 to a binary number. Here we're going to use base exponents and place values. Base exponents, as we're dealing with binary, is 2. 2 to the power 0, 1, 2, 3 will give us the place values. 2 to the power 0, 1, 2 to the power 1, 2, 2 to the power 2, 4, up to 2 to the power 7, 128. So we're converting base 10, 96 base 10 to 128. So with these place values, wherever the place value is greater than 98, we put 0. When it is less than or equals to 98, we put 1. With our first case, 128 is greater than 96. Let me just write it down here. The first one, we're dealing here with 96 base 10. 96 base 10. Let's come back to our number. Good. 96 base 10. So in this case, here we have 0 because 128 is greater than 96. 64. 64 is less than, so we put 1. It's less than 96. Okay. While the level of 64 is taken. 64 is taken. 64 is taken. It's taken. Plus, what's the next number? The next number is 32. 32 plus 64. 32 plus 64 gives us 96, which is the value itself. 96, which is the value itself. So here we put our 1. Then we just put 0, 0, 0, 0, and 0 in the other direction. So what will be our answer? Our answer will be 0, 1, 1, 0, 0, 0, 0, base 2. That's the answer for the first one. The second part of the question is asking us to convert this binary number to an octal number. To convert the binary number to an octal number, we group the binary numbers into groups of 3 starting from your right to left. So to do that, let's start with the first one. And you have here 0, 1, 1, 0, 0, 1, and 0, and 1, 0, 0, because we need to add these numbers to fill up to make it complete. Yeah. So we have next 0, 0, 0, and we have next 1, 1, 0. These are the 3 numbers from right to left. 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. Here is it. 0, 0, 0. Here is it. And 1. Here is it. We don't need to add some zeros in form to make them 3. Let me just import a table there that will help us in this work. Insert the text box. There's this table there. Let me crop for better sight. Okay. As we are dealing with octal, this is binary octal, we're dealing with octal and we're dealing with 3 bits. So the bit on your left, we have to delete that. Will not be important for this. This one, like this, let me remove it. It's not important for this study. Let me take the weight, the biggest weight. Can even make it black. Oh, the weight. Good, that is not needed. So let's continue down. 0, 0, 1, 0, 0, 1. Here is octal 1. 0, 0, 0 is octal 0. 1, 1, 0 is octal 6, which means that this number to binary equals to octal, I beg your pardon, equal 106 base 8. Yes, I think it's okay for this question. Good, okay. Let's now move to the C part of the question. The C part of the question. The C part of the question gives 2 ways each that a computer can be useful to a student, teacher, government, and a journalist. Okay, to a student. In our case, you computer students, you always use computers to do computer practicals in your labs or at your homes. Yeah, so a computer is useful to carry out computer science practicals. You also use a computer as a student to study online during this our Corona break. That's why we're using, even a phone is a computer, you know that. So we're using a phone or a PC to study online. You can also use it as a student for research and entertainment. In research, maybe you go online, Google, Wikipedia, or Encanter for research, entertainment, you use it to play games and all those other things, watch a movie. For a teacher can use a computer to computerize his notes and store them online in your Google Drive or your Google account. Yeah. A computer can also use it for online teaching. During our Corona break, while students were using it for learning, teachers were using it for teaching. Teachers can also use the computer to update their notes, not to be using archaic notes. IT is changing, so you have to use it to update your note, make research also. And for entertainment, for the government can use a computer to keep records, to produce your ID cards, gather statistical information in such areas as the society, the education, the environment, commerce, and the economy. They also use it to pay out salaries. Yeah. For the journalists, for television broadcasts, publishing, finished articles. Good. That is good for that. The G part of it, define the following terms as used in database. Foreign key. A foreign key is a primary key. Is the primary key. A foreign key is the primary key or a primary key of another table. Look at this example. Here we have a student table and a teacher table. In this student table, we have the student candidate number as the primary key. And on the teacher's table, we have the teacher's ID as the primary key. What is, first of all, a primary key? A primary key uniquely identifies each record in a database table. Let me take a good example. In your country, you can be considered a primary key. When you travel and you go to another person's country, you are a foreigner there. So at that point, you are known as a foreign key. In your country, you are a primary key. In a foreign country, you are a foreign key. So in this case, the student candidate number here is the primary key on the student table, and the teacher ID is the primary key on the teacher's table. Okay, look at this relationship. To create a relationship, that's what we call concatenation, the migration of primary key to be a foreign key in another table. So here, for this relationship to be created, the student candidate number migrated from the student table to the teacher's table. Here is it. At this point, it's called the foreign key, creating a relationship between the student table and the teacher table. So what is a foreign key? A foreign key is just a primary key of another table or of a mother table. Okay, the last one, data redundancy. Data redundancy is defined as the storing of the same data in multiple locations. Look at this database table. You have here student name, Peter, Besem, Amina. Practical, this student, Peter, is doing ICT practical, biology practical, Besem is doing biology, Amina is doing ICT, biology, and chemistry. These are the addresses. When Bam wind up, teacher, these are the teachers teaching the various subjects, practical subjects, and their cell number. If you realize this, there's a lot of repetition here. There's ICT here, ICT is here, biology is here, here, and here. Then these names here, here, Laura here, and here. Phone numbers are also repeating. So that's what we call data redundancy in a database. That is the storing of the same data in multiple locations. Okay. This is the question 3 of this question paper, the Southwest Regional Mock Ordinary Level. If you don't have this paper, just click on the link below to download this question paper, and don't forget to subscribe and click on like. In my next video, I'm going to answer the question 4. Thanks for watching, and see you guys in the next video.